In recent years, India has switched to green energy or non-conventional sources of energy, that is wind energy. Wind energy is produced by windmills. As the name suggests, windmills derive their power from wind. In other words, the wheels of windmills rotate according to the motion of wind. But what is wind? The moving air is called wind. Wind may be as pleasant as breeze that causes the flowers to bloom. Winds can also be as violent as thunderstorm that may uproot the trees. In this video, we see that winds blow at different velocities. So now let us discuss the factors that affect the direction and velocity of wind. I hope all of you can recall this picture. This picture shows the different pressure belts of the world. From this picture, we can understand that the air pressure conditions are not even throughout the globe. There are some places where low pressure exists, while there are other places where high pressure exists. Now, to balance or equate the air pressure conditions, winds blow. Rather, this difference in air pressure condition causes horizontal movement of air. So, this horizontal movement of air in response to difference in pressure conditions is called wind. We learned that the horizontal movement of air is called wind. Now, apart from this horizontal movement, there also occurs vertical movement of air, that is ascent or rising of hot air and descent or sinking of cold air. So, this vertical circulation of air is called air current. And air current occurs due to variation in temperature, that is rising of hot air and sinking of cold air. So now let's quickly recapitulate the difference between wind and air current. Wind is the horizontal movement of air caused due to changes in air pressure conditions, while air current is the vertical movement of air caused due to variation in temperature. Now, these winds and air current consist of the entire air circulation throughout the globe. Now, we will discuss about the factors that affect the wind flow. If you remember, we have seen this map earlier. In this map, these lines are isobars, and isobar is an imaginary line that joins all places having equal atmospheric pressure. Now, as we move from one isobar to another, the air pressure condition changes. See, here the atmospheric pressure is 1024 MB, but as we move from this isobar to this one, the air pressure decreases and it decreases to 1020 MB. So, this rate of change in air pressure between 2 points on two different isobars is known as pressure gradient. So, pressure gradient is the rate at which pressure changes. We will now calculate pressure gradient. See, in this isobar, the air pressure is 1024 MB. As we discussed, here the air pressure is 1020 MB. So, here we can see that air pressure decreases by 4 MB. So, the pressure gradient here is 4 MB. Now, you can calculate the pressure gradient for rest of the isobars. Now, how does this pressure gradient affects wind flow? We know wind flows from high pressure region to low pressure region. So this is high pressure region and this is low pressure region. So wind will flow in this way from high pressure region to low pressure region. But apart from this, wind flow also depends on pressure gradient. The closely placed isobars shows low pressure gradient because here the rate of change in atmospheric pressure is less in this particular region, whereas the isobars that are far away from one another shows high pressure gradient because here the rate of change is higher. So here the pressure gradient is more. Now in regions where the pressure gradient is more, the winds will flow at a higher rate, whereas in regions where pressure gradient is low, the winds will flow at a lower rate. This is how pressure gradient affects the wind flow. Now another factor that affects wind flow is Coriolis force. We know Coriolis force is caused by Earth's rotation. Now this force deflects the wind flow. So let me explain you how the direction of wind changes. As the winds blow towards the pole from the equator, the wind gets deflected to the right. In other words, the wind rotates clockwise in northern hemisphere. On the other hand, the wind blowing towards the south from the equator gets deflected to the left. In broader sense, the wind rotates anti-clockwise in southern hemisphere, and this deflection is caused due to Coriolis force, and Coriolis force is caused by Earth's rotation. So here we see that the direction in which the wind blows depends on Coriolis force. So Coriolis force is another factor that affects wind flow. So till now we have discussed the meaning of wind and the factors that affect wind flow. Now winds are of various types. So let us now discuss about different types of winds one by one. Look at this wall map. This wall map shows the major deserts of the world. In this map, we can observe that the deserts are mostly located in the western margins of the continent. That is, Sahara Desert and Kalahari deserts are located in the western part of Africa. Again, Atacama Desert and Great Basins are located in the western part of South America and North America respectively. Similarly, Australian desert is also located in the western part of Australia. So we can see that most of the deserts are located in the western margins of the continent. But why? The existence of these deserts depends on the direction of the prevailing wind. That is, the winds blowing in this direction blows in one particular direction, which has resulted in the formation of these deserts. So the winds that blow in a particular direction from high pressure to low pressure belt are known as planetary winds. Now in this picture, the arrows shows the direction in which the planetary winds blow, and we can see that these planetary winds blow constantly in one particular direction. In fact, these planetary winds follow this particular direction throughout the year, and due to this reason, planetary winds are also known as permanent winds, because these winds never change their direction. Now, permanent winds are of various types. Now, since permanent winds follow a particular direction, Therefore, these planetary winds are named after the direction in which they blow. We will now discuss about various types of permanent or planetary winds. The first type of planetary wind is trade winds. Trade winds blow from subtropical high pressure belt to equatorial low pressure belt. Now, this is very easy to remember the direction of trade wind. Just remember one thing, that winds always blow from high pressure region to low pressure region. Now, since subtropical pressure belt is a high pressure belt and equatorial pressure belt is a low pressure belt, therefore trade winds blow from high pressure belt to low pressure belt. And similarly, in the southern part also, they blow from subtropical high pressure belt to equatorial low pressure belt. So, these trade winds flow in this direction, from subtropical high pressure belt to equatorial low pressure belt. They blow as northeast trade winds in northern hemisphere and as southeast trade winds in southern hemisphere. Now, in the northern half, it is known as northeast trade winds because, as you can see, they blow from northeast direction, or they blow in northeast direction. And in the southern half, they are known as southeast trade winds because, as you can see, they blow from or in southeast direction, and due to this reason they are known as southeast trade winds. Also, these permanent winds are known as trade winds because the word trade means blow to tread, where tread means a steady direction. And since these winds are known for their steadiness or persistent direction, so these permanent winds are also called trade winds. Now, these trade winds can be onshore winds and offshore winds. Now, what are onshore winds? Now, onshore winds are the winds that blow from sea to land. Now, as these winds blow from sea to land, they pick up moisture from the sea and cause rainfall in the eastern coast of the continents. Now, look at this picture carefully. In this picture, we can see that there are some trade winds that blow from sea to land. So, these winds pick up moisture and they will hit the eastern coast of the continent and they cause rainfall in the eastern coast of the continent. Now, trade winds can also be offshore winds. Now, offshore winds are the winds that blow from land to sea. Now, since these winds blow from land to sea, therefore, these winds are dry, that is, they do not contain any moisture, and therefore, they cause no rainfall to the western coast of the continents. Now, look at this picture. In this picture, we can see that there are some trade winds that blow from land to sea. Now, eventually, they will hit the western coast of the continents and they cause no rainfall to the western coast of the continents. Now, another characteristic of this wind is that they blow in a particular direction. That is, they blow from northeast to southwest in the northern half. See, they are blowing from northeast to southwest in the northern hemisphere, while in the southern hemisphere they blow from southeast to northwest in the southern half. This part is southeast and they are blowing from southeast to northwest. And as we can see, both these winds converge at the equator. That is, at 0 degree or the equator, both these winds converge. So these are the different characteristics of trade winds. Now, in the previous slide, we saw that northeast trade winds blow from northeast to southwest in the northern hemisphere, while the southeast trade winds blow from southeast to northwest in the southern part. And both these winds converge at the equator, and due to this reason the equatorial low pressure belt is also known as ITCZ or intertropical convergence zone. So both the trade winds converge at this equatorial zone. Now, due to the existence of these trade winds, and because these trade winds also flow over water bodies, these trade winds results in storms and rainfall, and due to this reason equatorial low pressure belt, although is a calm region and known as doldrums, experiences stormy and rainy weather because of the prevalence or existence of these trade winds, because some of these trade winds are also onshore winds which carry moisture and they cause rainfall. So equatorial region, although being a calm region, experiences stormy weather because of the existence of trade winds. We will now discuss about another type of planetary winds. Now, before we proceed with our lesson, let us try to answer this question. Which pressure belt is known as intertropical convergence zone? Is it the subtropical high pressure belt, polar high pressure belt, equatorial low pressure belt, or subpolar low pressure belt? Well, the correct answer is equatorial low pressure belt is also known as intertropical convergence zone, because here both the trade winds converge at the equatorial region. So the correct answer is equatorial low pressure belt. Another type of planetary winds is westerlies. Now westerlies blow from subtropical high pressure belt to subpolar low pressure belt. Again, as we can see, winds blow from high pressure belt to low pressure belt. Now subtropical pressure belt is a high pressure belt and subpolar pressure belt is a low pressure belt. So westerlies blow from subtropical high pressure belt to subpolar low pressure belt, as we can see from the picture. Now also note that this type of planetary winds is called westerlies because they blow from west in both the hemisphere. In northern hemisphere they blow from west, and in southern hemisphere also they come from west, and due to this reason these planetary winds are also known as westerlies. Now unlike trade winds, the motion or the direction of westerlies is not steady. This is because westerlies are disturbed or interrupted by frequent cyclones. Now in temperate region we often experience cyclones. We will read about temperate cyclones later. But for now, just remember one thing, that unlike trade winds, the motion of westerlies is not steady as they are interrupted by frequent cyclones. Now westerlies can also be onshore winds. And as we have discussed, onshore winds blow from sea to land and they bring rainfall. And westerlies also cause rainfall to the eastern coast in temperate zone. Now we know westerlies blows from west to east. So these winds hit the eastern coast of the continents and they cause rainfall in the eastern margins of the continents. Now let's learn about the direction of westerlies. Westerlies blow in southwest direction in the northern half and in northwest direction in the southern half of the globe. In this picture, we can see that the westerlies blow from southwest in the northern half and from northwest in the southern half of the globe. We know trade winds blow from southeast to northwest, while westerlies blow from northwest. So we can see that trade winds and westerlies blows in opposite direction. Similarly, in northern hemisphere also, the trade winds blow from northeast to southwest and the westerlies blow from southwest. So they move in opposite direction, and due to this reason westerlies are also known as anti-trade winds, because they flow in a direction opposite to that of trade winds. So these are the characteristics of westerlies. We will next study about another type of planetary winds that are prevalent in the polar region. Now, another type of planetary winds that are prevalent in the polar region are also known as polar winds or polar easterlies. Now, these winds also blow from high pressure to low pressure region, that is from polar high pressure belt to subpolar low pressure belt. Now, in this picture, we can see that the polar winds are blowing from polar high pressure belt to subpolar pressure belt, which is a low pressure belt. So the polar winds blow from polar high pressure to polar low pressure belt, both in the northern and in the southern hemisphere. Now, polar winds are also called polar easterlies because they come from eastern direction. See, in the northern hemisphere they are blowing from northeast, and in the southern direction they are blowing from southeast. So polar winds are also known as polar easterlies because they come from eastern direction. Now, polar winds are unsteady in the northern hemisphere while they are steady in the southern hemisphere. Polar winds blow steadily in the southern hemisphere because, if you can recall, in the southern pole we have a continent or a landmass, that is Antarctica, whereas in the northern part we have water bodies as well as land masses. So the flow of polar easterlies gets interrupted by the presence of land masses and water bodies in the northern half. So in the northern half they blow unsteadily, whereas in the southern half they blow steadily. Now, polar easterlies or polar winds are extremely cold and dry winds because they originate in the polar regions where there is very low temperature and also the humidity is low. So polar winds are usually very cold and they are dry winds, that is the moisture content of these winds are less. Now, polar winds blow in northeast direction in the northern half and in southeast direction in the southern half. Look at this picture. In this picture we can see that the polar winds come from northeast direction in the northern hemisphere and they come from southeast direction in the southern hemisphere. So since the polar winds come from east, so these polar winds are also known as polar easterlies. Now, if you remember, I mentioned that westerlies are frequently interrupted or disturbed by cyclones. So westerlies are unsteady. Now, these cyclones occur because polar winds converge with westerlies. In this picture, we can see that the polar winds are blowing from polar high pressure belt to subpolar low pressure belt, and westerlies are coming from subtropical high pressure belt to subpolar low pressure belt. So in this region, both the winds converge. And since polar winds is comparatively cooler while westerlies are comparatively warm, so the convergence of this cold and warm wind results in the formation of cyclones mainly in the temperate region. And because of this reason, the flow of westerlies gets obstructed or interrupted. So these are the different characteristics of polar winds or polar easterlies. Now here we have the summary chart on permanent winds or planetary winds. Planetary winds or permanent winds, as we discussed, blow in one particular direction. And we also know that permanent winds are of various types, that is trade winds, westerlies and polar easterlies. Now this picture shows the different types of planetary winds that exist all over the globe. These planetary winds are named according to the direction from which they blow. Trade winds blow in northeast direction in northern hemisphere and in southeast direction in southern hemisphere. Westerlies blow from west in northern and southern hemisphere, and therefore they are called westerlies. Polar winds come from northeast direction in northern hemisphere and southeast direction in southern hemisphere. And since polar winds come from east in both the hemisphere, therefore they are also known as polar easterlies. So these are the different types of planetary winds. So in today's video, we discussed what is wind. Horizontal movement of air caused due to change in pressure conditions is known as wind. We also understood the difference between wind and air current. And then we discussed about a particular type of wind, that is planetary winds. We also discussed about different types of planetary winds. In our next video, we will discuss about other types of winds, that is periodic winds and local winds. Don't forget to subscribe to our channel and hit the bell icon. You can also register for free at DeltaStep.com or download the DeltaStep app to learn one-to-one with our amazing teachers or to get access to our 5,000 amazing videos as per your school syllabus. Master each topic with our adaptive practice technology. Get million+ questions with step-by-step solutions and unlimited mock tests. Get all your doubt resolved instantly. Learn via games and win amazing prizes like PlayStations and iPads. So at DeltaStep, learning is not just fun and easy, but it's rewarding too. So register for free now.